Hello Year 9s, this is Mrs Elliott's hand, and I'm going to start our revision process with this video today. Now, at the end of Year 9 exam, and we don't yet know when that's going to be, we are going to be answering questions on chapters 1 to 9 from the GCSE textbook. So over the next half term, we are basically going to revise those chapters, and largely we're going to do them one per week. But today we're going to have a look at chapters 1 and 2, just because there isn't that much in chapter 1. Most of it, I think, is stuff that you already know very well and that you learnt in year 8. So just a quick recap then on chapter 1. Okay, so chapter 1, things that you need to be able to do. So rounding is one of the main things in chapter 1. And that is rounding to a certain number of decimal places, to a certain number of decimal places. And I think all of you will be fine with that. So rounding to a certain number of decimal places, if I had the number 3.6594 and I said, can you round that to one decimal place? You would all go to one decimal place, look at the next one and say that is a 5 or more, so I'm going to round this one decimal place, this first decimal place, up. If I'm rounding to 2 decimal places, I go 3.65, I take a little peek at the next decimal place. It again is between 5 and 9, and therefore I'm going to round up. So to 2 decimal places, I'd be at 3.66. 3 decimal places, go 1, 2, 3 decimal places past the decimal point. Look at the next one, it's a 4, that is below 5. So I leave my 9 as it is, so 3.659. And then finally to 4 decimal places is already there. Now, one just little thing just to bear in mind, if I'd had 3.6595, so if 3.659, so 595 was the one that I was rounding to 3 decimal places, I would go to 1, 2, 3. That 9, looking at the next decimal place, would have to go up. So that 9 would have to go up to a 10, which would make that a 6. So it would be 3.660. So just to recap, if that number had been a different number, if it had been 3.6595, when I'm rounding to 3 decimal places, 1, 2, 3 decimal places, take a peek at the 4th decimal place, it tells you to round up. So that's got to become a 0, that's got to become a 6, yeah? So it's going from 59 to 60, effectively. Okay, so rounding to a certain number of decimal places, you should be fine with. The other things in this chapter are rounding to a certain number of significant figures. Now, significant figures don't just take place after the decimal point. Significant figures, that's 7392.8654. Let's have a look at that. Yeah, okay. So with this number here, our first significant figure is the 7. And therefore, if you were rounding this to one significant figure, you would stop at the 7. Now, the problem is, if you just wrote the number 7, you'd be rounding a number that is 7,392. You'd be rounding it to 7. That can't be right, can it? So if you have not yet reached the decimal point, you must replace the other numbers with zeros. So this number to one significant figure is going to be 7000. Okay. If I want to round it to 2 significant figures, I start to apply the same rules as I did with the decimals. So 7 is my first significant figure, 3 is the second. I take a peek at the next number. The next number is a 9, that is a 5 or more, and therefore I'm going to round this 3 up to a 4. However, it makes no sense for 74 to be 7,392 point something to two significant figures. You must fill the gaps with zeros. See where I'm going with this? So 3 sig figs would be 7390. 4 sig figs would be 739. Look at this 9. Sorry, look at this 2, which is the fourth significant figure. 1, 2, 3, 4. Look at the next one after the decimal point. It's an 8. So I will round it up. And then you just start applying the same things with the decimals. So if I'm going to 5 significant figures, I would be 7392. Look at the fifth. The fifth one is an 8, but take a look at the next one that comes after that, and it will be 0.9, etc. Those dots shouldn't be there. Okay, so rounding to a certain number of significant figures. Your significant figures start as soon as you get a number that isn't a 0, okay? Just going to look at one other example. I'm going to look at the number 0. Oh, this isn't a very good pen. Let's throw this one away. Find another one. Let's look at the number 0.4506, okay? So if I am rounding this to one significant figure, I'm going to take my, I need my first significant figure is 0. Sorry, my first figure is 0, but it's not a significant figure. So I go to the first non-zero number, which is the 4. I take a look at the next digit, and the next digit is a 5, therefore I round it up. So I've given one significant figure. This 0 here doesn't count as a significant figure, but we need to have it there to show us that we have gone beyond the decimal point, that we're in the decimals. Yeah, and thereafter, all figures count, okay? So 2 sig figs will be 0.45. 3 significant figures, this 0 does count as a significant figure, but actually, when we're rounding to 3 significant figures, we would look at the next one, and it would be 0.45. That would go up to a 1 because that's a 6. Yeah. Okay, so that's rounding, and I think you can probably all do that and have been able to do it for a long time. Just be careful with it. There might be a question that literally just asks you to round some numbers to a certain number of significant figures. But what's more common is that you do a question on a completely different topic and they ask you to round your final answer to a certain number of decimal places or significant figures. And that's where you get that final mark in the question for doing your rounding correctly. The other things that are in chapter 1, there's a little bit on working with decimals, and that means doing calculations with decimals. So let's just say I've got 13.05 and I want to add or subtract 6.23 to it. Just got to be able to do that. That's standard addition using a column method. Yeah. If it was a subtraction, then you would be doing the standard thing as well. So here, 5 minus 3 is 2. We can't do it as 0 minus 2, so we borrow from there. 10 minus 2 is an 8. Keep that decimal place in place. 2 minus 6 we can't do, so we borrow from there, make that into a 12. We end up at 6.82. So those are normal calculations. You've just got to remember to keep your decimal places in line. Okay, so adding and subtracting with decimals is exactly the same as adding and subtracting without the decimals. Sorry, I should have kept it there. But keep your place value by keeping your decimals in line, your decimal points in line. With multiplication and division, what my top tip always is to actually get rid of the decimal points and to use whatever your normal method would be. Now, think about 13 times 6. It's going to be a number that's either in the 60s or 70s, isn't it? 13 times 6, yeah? If you're accurate, if you know, then it's actually going to be 78, yeah? 6 times 10 is 60, 6 times 3 is 18, so 78, yeah? Thereabouts. So our answer, we know, is going to be roughly 78. If you take the decimal points out, you can then just do this as a normal multiplication sum, yeah? So taking our 3 5s are 15, 5 down, carry the 1. 3 times 0 is 0, so that 1 goes in there. 3 3s are 9, 3 1s are 3. Put in a 0 because we're now multiplying by 20, not by 2. So 2 times 5 is 10, 0 down, carry the 1. 2 times 0 again is 0, so that becomes 1. 2 times 3 is 6, 2 times 1 is 2. And now we're multiplying by the 600, so we're going to put 2 zeros in place. 6 5s are 30, 0 and carry the 3. 6 zeros are 0, so that becomes a 3. 6 3s are 18, 8 down, carry the 1. 6 1s are 6, plus 1 is 7. So I'm going to put all my decimals in, all my digits in by adding up. 0, carry the 1. 4, 10, 13, carry the 1, 9, 11, carry the 1, 8. Now I've got 813,015. I know that I've got an answer that's roughly 78, so my decimal place would go there. Yeah. And that's the main thing to do with these sorts of questions. What you really want to do is to check for yourself roughly what the question is going to give you as an answer, and then do the whole calculation without any decimals. And only at the end you must remember, obviously very important to remember, to put the decimal place back in. Yeah. Final thing, division. I know you all hate doing division calculations longhand, but it may come up, so I think you do need to be able to do it. So I'm going to use the same numbers. So I'm going to use 13.05 and I'm going to put in 6.23. And I'm going to ask for an answer to 2 decimal places. Yeah. Okay, it won't go in exactly, but I know that 6 goes into 13 twice, just a bit more than twice, yeah? So what I've really got to do here is just see what I've got in terms of this, and see what twice actually gives me. So I know it doesn't go into 1. 6.23 does go into 13. So 6.23 times 2 is going to be 6, 4, 12.46. 12.46, so that goes in twice. 12.46, that's going to give me, so I'm going to do 13.05 minus 12.46. I think that's going to give me, let me just do my little calculation. I hope you can see this down at the bottom here. So 5 minus 6 I can't do, so I can't borrow from there, so I can borrow from there. 10, that makes that a 9, that's a 15, so that's a 9, that's a 5.59, so I've got 5, 9 to take across. 623 into 590, I have given myself a hard sum here, haven't I? Okay, 623 into 590, I reckon that's going to go probably 8 or 9 times. So 6.23 times 8, using my work that I've done before. I'm going to just give myself an answer to 1 decimal place. Actually, I've decided to make this a bit easier. 8 3s are 24, 4 down, carry the 2. 8 2s are 16, plus 2 is 8. That's 8 down, carry the 1. And 8 6s are 48, and that's 49.84. I think I can probably fit another one into there. So I can probably fit in 6.23. I could probably fit it in 9 times into into the 59. So I'm going to go for 623 times 9. Let's just check it. 623 times 9, that's 27. 9 2s are 18, that's 2. 9 6 is 54, 56. Yeah, that will fit in 9 times. So I am fitting that in 9 times, and then I've got something to carry over, but I'm not going to go any further. So 6.23 goes into 13.05, 2.9 times. That's much harder than any one that they'd give you, and that's because I made up my numbers, so I apologise for that. But you can see where I'm doing my workings. I'm doing these little calculations, and I am essentially ignoring the decimal points until the end, and then I'm putting them back in. So that's the key thing with operations with decimals. And then the last thing in chapter 1 is negative numbers. And you just need to remember the rules for negative numbers, or negative, working with negative and positive numbers. So the rules. If you are adding or subtracting, all you do is move up and down the number line. Okay, so remember the number line. So here's my number line, and here's 0 on it. Okay, so if I have got the number 6 and I'm subtracting from it 8, I am starting at 6 on the number line. I am going back 8. So 1, 2, 3, 4, 5, 6 gets me to 0, and another 2, 7 and 8 gets me to -2. Yeah, so that's what you're doing with the number line. Things that sort of people do get a bit confused about are if you've got 6 minus -8. Well, if 6 minus 8 takes you in that direction, if taking a number away takes you in that direction, takes you into the negative numbers in this case, if you are doing the opposite of taking away, you must be adding, yeah? And that means that you've just got 6 plus 8, which goes in the positive direction on the number line, which gets you to 14, yeah? What people get a bit confused about as well is if you have this notation, so instead of 6 minus 8, you have 6 plus -8. Well, this plus is just saying just do a -8. It's just saying just and -8, which is just the same as saying 6 minus 8. Yeah, if you think 6 plus 8 is going to take you that way, 6 plus -8 must take you back in that negative direction. So it's exactly the same as the calculation above. Yeah. So when you've got two different signs written next to each other, you will always end up with a negative here. So that would just be replaced with 6 minus 8. When you've got two signs the same written next to each other, that would be replaced by a plus. And then you're thinking about the direction you go on the number line. Draw yourself a number line, think where you start on the number line and the direction you're going. Negative direction takes you down the numbers, and a positive direction takes you up through the numbers. And then multiplying and dividing. With multiplying and dividing, you've just got to remember the rules of these. Multiplying and dividing. So if you've got two signs the same, then it gives you a positive answer, and two different signs, you get a negative answer. Yeah, so examples here. So -3 times -2. Those are two signs the same, so you just do 3 times 2, which will give you 6. Yeah, it's going to be a positive 6. Don't have to write the positive in, but I'll write it there just to make it clear. Whereas minus 3 times 2, you've got a different sign in front of each of these, and therefore that's going to give you a minus 6. The thing that a lot of you, I think, got wrong when you were doing some of those functions questions was when you get something like minus 9 squared. Now remember, if you put minus 9 without any brackets into your calculator and square it, you'll get minus 81. But what minus 9 actually squared actually means is minus 9 times minus 9, which is plus 81. Yeah, so just be very careful. If we had minus 3 and instead of squaring it we were cubing it, think about this. That would be minus 3 times minus 3 times minus 3. That's what it means. The minus 3 times the minus 3 here, they're two signs that are the same. So that's going to give you 9 plus 9. And then that is multiplied by minus 3. So you've got a positive multiplied by a negative, and that would give you minus 27. Yeah, so the cubing of a negative number, because that negative sign gets cancelled out by multiplying twice, and then comes back in again by multiplying by the third time. Okay, exactly the same rules apply for dividing as well. Okay, so that's chapter 1. So if you want to, you can just pause there, make any notes that you need to. Chapter 1, you've got a little caboodle test to do on that, but you may have already done it. So I'll just rub this lot out. Main thing I wanted to have a quick look at today was chapter 2. So chapter 2 is all about algebra, and it's specifically about algebraic expressions. So a few reminders of things here. Now I think you all know about collecting like terms, so some of my examples that I'll do in a moment are to do with those, or I've got those at the end of them. We'll do them then. What I do want to remind you about are rules of indices, which you may or may not remember. So hopefully you're taking notes as you're going through, if you remember these. So rules of indices, now these apply in algebra and in numbers, so we'll do some examples of both. If you've got, now this number here, as I've said it's a number, but it's actually a letter in this case. This is going to be my base number or my base letter, and I'm raising it to a power, and the power that I'm raising it to is an m. Okay, m can be any number, but it's a power, it's written up there. So that means that it's a multiplied by itself m times. If I multiply that by a to the n, where n is a different number, remember this is the same base, then the rule is that the answer that you get is the same base raised to the power of m plus n. And I'm just going to illustrate that with an example. So let's say I had, let's go for some small numbers, a squared times a cubed, okay? That is going to be, so this a squared is going to give me a times a, and this a cubed is a times a times a. We are multiplying that lot together. So how many a's have we got? 1, 2, 3, 4, 5. That's going to give me a to the 5, which as you can see is 2 plus 3. Yeah, so that's how this works. If you've got the same base, so in this case it's a, if you raise each of those bases to a different power, the power that the product of them, so when you're multiplying them together, what you get is the power is the sum of those two powers. Yeah, this works with numbers as well. So if I had 10 to the 5 times 10 to the 6, my answer would be 10 to the 5 plus 6, which is 10 to the 11. Yeah, so hopefully that example sort of illustrates that rule. Now, we can do a similar rule for division. A to the m, so again we're working with the same base. It has to be the same number that's the base. Yeah. A to the m divided by a to the n, the rule for this is a to the m minus n. So the one on the top minus the one on the bottom. Again, I'm going to give you a little example, a little illustration. So let's say that we had a to the 7 divided by a cubed. Yeah, we know, and that means 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7 a's on the top divided by 3 a's on the bottom. Now, because they're multiplied together, we can cancel out one from the top with one from the bottom, one from the top with one from the bottom, one from the top with one from the bottom. What are we left with? We're left with 1, 2, 3, 4, which is a to the 4. A to the 4 is 7 minus 3. And again, we can do the same with numbers. So we could have 5 to the 10 divided by 5 to the 4. And our answer would be 5 to the 10 minus 4, which is 5 to the 6. These rules are really important. They come up a lot. So they come up in algebra, so with letters, x's and things. But they also come up in number work as well when you're looking at what we call indices, powers. Yeah. So if you haven't got a note of those with those examples, then please do make a note of them now. I'm just going to move on to a couple of others, and then we'll do a couple more examples. Right. Next one of our rules of indices is if you've got a base number again, raised to a power, n in this case, and you've raised the whole thing to another power. The rule is that the solution is a to the nm. Yeah, the two powers get multiplied together. So let's just think about how that would work. So let's just say that I've got a cubed raised to the power of 2. What does that mean? So that means a cubed, we know, is a times a times a. If I'm squaring it, I'm timesing it by itself. So that's going to be a times a times a times a times a times a, which is a to the 6. A to the 6 is 3 times 2. Yeah, so the rule is a to the m or n, m means you multiply those two together. Yeah, which is the same as 3 times 2. So no need to do all of this working. You can go straight to that answer there. Yeah, and similarly, as I said before, it works with numbers. So if I had a to the 5 raised to the power of 4, I could go straight to a to the power 8 to the power of 5 times 4, which is 8 to the 20. So it works with numbers, works with algebra. And then just one special rule to remember. So that rule is called the power rule. The special rule to remember as well is that anything raised to the power of 0 is always 1, with one exception, and that is 0. Yeah, except where a is 0. So anything raised to the power of 0 equals 1. So that means that x to the power of 0 equals 1. That means 17 to the power of 0 equals 1. Yeah, anything to the power of 0 is 1. Okay, right, just going to do a few examples of these for you, because I can see that these ones are some of the slightly harder ones, and we're just going to apply these rules for those examples. So I am going to do a multiplication one, a division one, and then a couple of power ones, because I think the power ones are sometimes the harder ones. So some examples. Example one. So what have I got? 3x squared times 5x to the 6. So I'm multiplying them together. So I multiply the whole of this term by the whole of that term. So the 3 and the 5 get multiplied together to give me 15. And then I've got an x squared and an x to the 6. I'm going to write them, actually I'm going to tell you what I'm going to do. Rather than writing 15, I'm going to show you what I'm doing. I'm multiplying the numbers together. The 3 times the 5 is the 16. And the powers, the x squared is going to get multiplied by the x to the 6. Okay, so 3 times 5, as I said before, is 15. I'm going to use my rule of multiplying same base to powers. I add those powers, so that's going to give me an x to the 2 plus 6, which is going to give me 15x to the 8. Yeah, you don't need to write this line in. I'm happy for you to go straight to this end bit. Yeah, you're multiplying the numbers together and you're multiplying the x's together with their respective powers. Okay, now an example for the division. So I've got 10y to the 6 divided by 5y squared. Remember, I like to write these as one over the other, but you don't necessarily need to, but I find it easier. So again, we're going to deal with the numbers. So dealing with the numbers, I've got 10 over 5, and then dealing with the letters, I've got y to the 6 over y squared. 10 divided by 5 gives me 2. Y to the 6 divided by y squared, our rule is that we subtract this power from that power. So it's y to the 6 minus 2 equals 2y to the 4. Okay, so that's our multiplication. This is our division, okay? With the division, we're doing a subtraction of our powers. With the multiplication, we're doing an addition of the powers. Now we're going to have a quick go at some of the ones where you're raising a power to a power. So I'm just going to rub this off. So raising a power to a power. So I've got 4a cubed all squared. Now what this means is that the whole of this bracket, everything inside this bracket has been squared, yeah? So I've got to square the 4 and I've got to square the a cubed. So I'm going to write that stage again. You wouldn't have to write this in your workings as long as you're happy with it, but I want you to see exactly what's going on. You're squaring everything in the bracket, so you must square the 4, you must square the a cubed. 4 squared is 16. A cubed squared, our rule where you're raising a power to a power is you multiply those two powers together. So that's going to be a to the 3 times 2, which is a to the 6. And final example, I'm going to have 3y to the 6 all cubed. Okay, so this means that I've got to take the 3 and cube it, and the y to the 6 and cube it. So the 3 is being cubed, and the y to the 6 is being cubed. Okay, 3 cubed is 27. Y to the 6 raised to the power 3, we multiply those two powers together. We're going to get y to the 18. that's that. Okay, right, so now I'm going to go and have a look at some algebraic expressions that are used in sort of practical examples, things like sort of areas and perimeters of things, just to remind you how these sorts of questions work, okay? So I'm going to write areas and perimeters. And hopefully this will give us a little bit of a reminder of some of our knowledge that we have. So here we go. So I've got a shape. It's a sort of funny L-shape shape. And I'm going for 6x squared y being this side length here. 7xy squared being that side length. 2x squared y being that side length. And 3xy squared being that side length. Now, what I want you to do is just think very carefully about what this shape is doing, and also just to make sure that you understand that this side length here and this side length here have got measurements that are in x squared y's. And this side length here and this side length here have got measurements that are in xy squareds, so they are different to each other. Yeah? So if I was asking you for the perimeter of this shape, we could just be clever and think to ourselves, well, if that came out there, we could draw a line, and so we'd have a 6x squared, a 6x squared, a 7xy squared and a 7xy squared, or we could fill in the gaps. And I think we'll fill in the gaps just because I think you could do with that practice, okay? So we've got a gap here on this side. It's one of the vertical sides. We know that this side length here in total is 6x squared y. This one here is 2x squared y. They are the same sort of term. They're x squared y terms. We've got 6 of them here and 2 of them here. So in this gap here, we must have 6 minus 2. We must have 4 x squared y's. Similarly, this horizontal side here, we've got a 7xy squared here and a 3xy squared there. 7 minus 3, we're going to have 4 xy squareds in there. So if you wanted to work out the perimeter of this shape, your perimeter, you just take each of the sides in turn. We'll tick them off as we do them. So we've got a 6x squared y, we've got a 7xy squared, we've got a 2x squared y, we've got a 3xy squared, we've got a 4x squared y, and we've got a 4xy squared. They always ask you to express things in their simplest terms. This isn't as simple as it could be. We've got some terms that are the same here. We've got x squared y terms. X squared y terms, we've got one that's there, we've got one there, and we've got one there. So altogether we've got 6 plus 2 plus 4, we've got 12 x squared y's. And with our xy squared terms, I'll underline these, that one, and that one. We've got 7 plus 3 plus 4, we've got 14 of those. So that is simplified, and they always want you to simplify. Yeah, they always want it to be in the simplest terms. I'm sure lots of you just thought to yourselves, well, clearly to go around here, I've got 2 lots of 6x squared y and 2 lots of 7xy squareds, and you would have got there much quicker. But I think this was good to illustrate the point. Also, we need it in order to calculate our area. Okay, so if we want to calculate the area of this shape, we need to divide our shape into 2 rectangles. Doesn't matter if we put a line across there or a line down there. I think we'll put our line down there. I'm going to call it shape A and shape B. So we're going to do shape A plus shape B. Shape A, our area is going to be our 4xy squared, so the horizontal there, 4xy squared, and it's going to be multiplied by 6x squared y. That's our shape A. Shape B over here, shorter side, is the 3xy squared, and it's going to be times by 2x squared y. 3xy squared times 2x squared y. Now we're going to use our skills of multiplying out our terms here, and we're going to have to, we're multiplying x's by x's, etc. So we're going to have to use our rules of indices as well. So multiplying out, we multiply our numbers together. 6 times 4 is 24. Multiply our x's together. We've got an x to the 1. Remember, we never write a power as a 1, but it is an x to the 1 times an x squared. The rule of the indices is that we add those powers together, yeah? Well, actually what I'm going to do, I'm going to write x times x squared just in there for you, just so you can see what I'm doing in a minute. Same here, y's, I've got a y squared and a y that I'm multiplying together, so it's a y squared and a y. You would not write this in your workings. You would go straight for 24, which we went for anyway. X to the 1 times x to the x squared is x cubed, and again we've got a y cubed there, yeah? Okay, on this one, 3 times 2, that's a 6, and then an x times an x squared, and a y squared times a y. Same idea, 6, add the powers, x cubed, y cubed. Final step, we must simplify. These terms are in the same, they've got the same x's and y's in them, and therefore we need to add them together to simplify. 30 x cubed y cubed is the area of that shape. Okay, so that's a little bit of work that uses our knowledge of powers, uses our simplification of algebraic expressions, and just has to make us think a little bit about sort of putting it into a context, in this case of a shape. Right, last little bit that we're going to do, actually not quite the last little bit, sorry. Next little bit that we're going to do from chapter 2, we're going to just do a bit of expanding and factorising. Now we've done some quite hard expanding and factorising more recently in chapter 6 of our books, so I think you should be fine with this work. So expanding brackets, I'm just going to go straight into some examples here. This is fairly simple expanding, just single brackets, but I just want you to make sure you're happy with it. Minus 7b, b minus 2. So an example here, so this is just single brackets, okay? So if we're expanding in a single bracket, we are multiplying the thing on the outside by each of the things on the inside, okay? So we're going to work with this expression here first, or this term here first. This 6b times b. b times b is b squared, the 6 stays, so 6b squared. And then the 6b gets multiplied by the minus 1. 6b times minus 1 is minus 6b. Now, be very careful. This next thing is all subtracted. What I would do is put a subtraction sign in here and a bracket around all of this so that we remember what we're doing is all going to be negative at the end, okay? So I've got 7b times b, that's going to give me 7b squared. And 7b times minus 2, 7b times minus 2, the 7 and the minus 2 are multiplied together to give you minus 14 and b. Now we'll multiply through by this negative, yeah? So I've got 6b squared minus 6b minus 7b squared, minus minus, which is a plus, we know, 14b. Final stage on this is just to simplify it. So our b squared terms, I've got 6b squared minus 7b squared. Think about your number line. So you are at 6 on the number line. You are taking away 7. 1, 2, 3, 4, 5, 6 gets you to 0. And then another 1 gets you to minus 1. So I've got minus b squared. Remember, we don't write the 1. And then I've got a minus 6b and a plus 14. 14 minus 6 is plus 8b. So there, you're thinking about this negative here. Yeah, you could have written it differently. You could have just done minus 7b squared and plus 14b. You could have gone straight to that line if you'd wanted to, but that would be using that negative sign. So just be careful with that negative sign, thinking about how you're going to deal with it. Yeah, but basically you're multiplying the number on the outside by both of the terms on the inside. You're remembering your rules of negative numbers. Okay, I'm going to do one more of these. If you want to just work ahead of me, you can definitely do that. So one more of these. I'm going to do 2m squared times m minus 3 in a bracket, another negative 7m squared and 4 minus m all in a bracket. So you can work ahead of me if you want to. So I've got 2m squared times the m squared times m. Adding the powers is going to give me an m cubed, but the 2 just stays because I've just got a 1 there. And then I've got 2m squared times minus 3. 2 times minus 3 is minus 6m squared. Got this negative. I'm just putting my negative there, but you can work with minus 7m squared if you'd like to. So 7m squared times 4 is 28m squared. Just 7 and 4 times 4. And 7 times minus m is minus 7. Sorry, 7m squared times minus m is minus 7m cubed. Yeah, minus 7. Sorry, 7 times the minus and the m squared times the m, which is m cubed. And that gives you 2m cubed minus 6m squared minus 28m squared plus 7m cubed. This minus sign outside the bracket changes the signs inside. If you just multiplied through by minus 7m squared, that would mean you'd go straight to there. Yeah, so you would have done minus 7m squared times 4. That gives you your minus 28m squared. Minus 7m squared times minus m gives you 7m cubed. And then the final stage is to simplify. Again, we must always simplify at the end. How many m cubes have I got? I've got 2m cubes and 7m cubes, so 9m cubes altogether. Minus 6m squared and minus 28m squared. So there's 0. I'm at minus 28 on the number line, and I'm taking off another 6. So I'm going in the negative direction. Minus 28 minus another 6 gets me down to minus 34m squared. Okay, last example for expanding brackets. I'm going to do another one of these sort of area type questions. And this one is going to be an area with an area cut out of it. So I've got a rectangle with a rectangle cut out of it, okay? And the area that I'm going to be interested in is going to be the shaded area, okay? So measurements that you need. 2x minus 1 is that length there. 2 is that length there. 4 is that width or length there. And 3x plus 2 is going to be that length of the bigger rectangle. So if I want to find the area of the shaded region, I would say it's going to be area of the big rectangle minus the area of the small inside rectangle. So the area of the big rectangle, it's always going to be your width times your length. So your area of your big rectangle is 4, and then we're going to use our brackets notation times 3x minus 2. And we're going to subtract from that the area of the small rectangle on the inside, which is 2 times 2x minus 1. And now all we have to do is work this through. So 4 times 3x is 12x, 4 times minus 2 is minus 8. I'm going to subtract from that all of this rectangle. 2 times 2x is 4x, 2 times minus 1 is minus 2. That is all subtracted, okay? So I'm going to end up with 12x minus 8 minus 4x minus minus 2, which is plus 2. Yeah? Putting the x's together, I've got 12 minus 4, so I've got 8 x's. And putting the numbers together, minus 8 plus 2 is going to give me minus 6. Yeah. Oh, minus 8 on the number line. Go up 2 in the positive direction, and that gets you to minus 6. So that is my total area. Now, this is in algebraic form. They could easily ask you for a question in this form. Just one thing to bear in mind again, of course, if you use minus 2 to multiply through, you would have gone straight to that line there. Yeah. Okay, right. So we've done expanding brackets. I think probably one of the last things I just want to remind you of is this business of factorising, which is the opposite of expanding brackets. It's when you have an expression and you want to put the brackets back in. We've done a bit of this with quadratics recently, so I'm getting through my pens today, aren't I? This pen's going. So factorising. Let's have a look at a few examples on this. So if you want to put the brackets back in to an expression like this, all you have to do is look for common factors. So what have both of these parts of our expression got in common? Well, the number 16 and 40. First of all, look at the numbers. What times table are they both in? Well, they're both in the 2 times table. They're both in the 4 times table. And in fact, they're both in the 8 times table. So you look for the highest common factor of both of those numbers, and that's 8. And I'm going to write HCF next to it, highest common factor. We did a lot of that in year 8. And looking at the A, well, there isn't an A in the second term in this expression, so no good there. But they've both got a B in them, so I'm going to put a B next to that. So my highest common factor of these two is actually 8b. And in the bracket, all you have to add into your bracket is what you would need in order for when the bracket's multiplied out for us to get back to here. Well, we want a 16, we've got an 8, so we need to times by 2. We want an AB, we've just got a B, so we need to times by A. Over here, we've got a 40, we've got an 8, so we need to times by 5, and it's a negative because it's minus. And we've already got a B, so that would work. And then my top tip is just multiply out in your head to make sure it works. And that's always my top tip for those horrible quadratics we've looked at recently as well, isn't it? 8 times 2 is 16, AB. 8 times minus 5 is minus 40, B. Yeah, that would work. Yeah. Let's just do one more. Let's do 7xy squared z, and add 35 yz squared. Okay, look at the numbers first of all for common factors. I'll call that EG1. And this one EG2. Look at the numbers first of all. They are both in the 7 times table. There is no times table higher than that they're both in. So put the 7 outside the bracket. Then look at the letters. There isn't an X in both of them. There is a Y in both of them. So we'll put a Y in. And there is a Z in both of them. So we'll put a Z in. Now we need to see what we need to multiply 7yz by to get 7xy squared z. Well, we need an x, so we've got to put an x in. And this has only got a single y, this has got a y squared, so we'd need to multiply by another y, so we need an xy. Here we've got a 35, we've only got a 7 outside our bracket, so we need to multiply by 5. We've got a y, we need a y, so that's okay. We've only got a single z, we need a z squared, so we'll put a z in there. Okay, and then just in your head, multiply it out. 7xy squared z, yeah, that works. 35 yz squared, yeah, that works. So that's factorising just with single brackets. Okay, gents, so that's the factorising bit of that. Now we're going to move on to the last bit, which is algebraic fractions. So probably your least favourite bit, I would imagine. So algebraic fractions. Are just what they say on the tin, really. They are fractions. So something over something else, a numerator over a denominator, but they are expressed in algebraic form. So I've got a one here. What we're going to do with these ones, we're going to simplify them. And actually, before we do one, let's just do something like 3 over 6. If I asked you to simplify 3 over 6, you would say, well, these have got a common factor. They've got a common factor of 3. 3 goes into the top once and goes into the bottom twice. So that would be your simplification of that fraction. We're going to do the same with our algebraic fractions. We're going to simplify them by finding their common factor. And we're going to do that using our factorising skills. Okay. So here I've got 6x plus 24 over x plus 4. What I'm going to do is I'm going to, step 1, I'm going to factorise anything that can be factorised. So on the top here, have I got anything that can be factorised? Well, both 6 and 24 are in the 6 times table. So I'm going to put a 6 outside a bracket, x plus 4 inside the bracket. And on the bottom, I've got x plus 4. Given that I've got an x plus 4 on the top and an x plus 4 on the bottom, I can cancel them out, dividing the top and bottom. They both cancel out to 1, so I end up with 6 over 1, which is just 6. So factorise, and then this step here is to simplify. Yeah, let's look at a slightly harder one. So we're still simplifying. We're going to start by factorising, and then we're going to simplify. So step 1, factorise. So on the top of my fraction, what have I got that is in both the 3x cubed and the 4x? It's just an x. So that's going to give me 3x squared plus 4 inside my brackets, yeah? X on the outside, got to be multiplied by 3x squared to get to the 3x cubed, got to be multiplied by 4 to get to the 4x. So that's my numerator. on my denominator, I've got a 9 and a 12. 9 and 12 are both in the 3 times table, so I can put 3 outside my bracket. And I've got an x in both of those, so the x can go outside the bracket as well. What do I need to multiply 3x by to get 9x squared? Well, I need to multiply the 3 by a 3 and the x by an x, so it ends up being 3x. And on the over here, I need a 12x, so I'll just put a plus 4. Now, my simplification stage, simplify. I'm going to see what I can do. The top and bottom of my fraction I've got in common. Now, I've chosen this one very specifically because you might think you can cancel your 3x plus 4 with your 3x squared plus 4, but you cannot do that. And that is because they are not the same expression, okay? The only thing that will cancel on the top and the bottom here, so things that are multiplied together, is the x and the x. Yeah, that is not the same as that, so they cannot cancel each other. Yeah, the 4s on their own cannot cancel each other. It's only things that are multiplied together. So you're going to be left with 3x squared plus 4 on the top and 3 brackets 3x plus 4 on the bottom. And that is as far as you can go with that simplification. No further than that. Yeah, so it's just the x's that are the thing that gets simplified. Okay, so that's simplifying algebraic fractions. We're now just going to have a look at the rules for adding, subtracting, multiplying and dividing. So adding, subtracting, multiplying and dividing. So adding and subtracting, if you remember with normal fractions, so let's just do normal fractions for the moment. 6 over 5 minus 3 over 7, shall we say? What's our rule here? We must get ourselves a common denominator. And the normal way of getting a common denominator, sometimes you can find a lower common denominator, but usually you just multiply these two numbers together. So we're going to end up with something over 35 minus something else over 35. Yeah? Multiply those two together. So if we've multiplied the bottom of this 6 over 5 by 7, we've got to multiply the top by 7. 6 7s are 42. And similarly, if we've multiplied the bottom of this fraction by 5, we've got to multiply the top by 5. We're going to have 15 over 35. We're now left with two fractions, both over 35. We can just subtract 42 minus 15 is 27 over 35. I don't think that simplifies any further. So that's our rule for adding or subtracting normal fractions. So the same rule will apply for algebraic fractions. So if I've got here 3 over x minus 2, which I don't need in a bracket at the moment, so I won't put it in a bracket. So this is my example. And I've got minus 2 over x plus 3. I'm going to apply exactly the same rules as I applied here. So I said to myself, I haven't got the same denominator, so I need to give myself a common denominator. My common denominator is going to be these two expressions multiplied together. So an x minus 2, x plus 3. That's going to be the same for both of my fractions. So if that is my common denominator, I have multiplied the bottom of this one by x plus 3. So I've got to multiply the top by x plus 3. 3 times x plus 3. I've multiplied my denominator here by x minus 2. So I've got to multiply the numerator by x minus 2. And now I'm going to multiply out the brackets on the top. I'm going to leave the ones on the bottom. I don't need to multiply those out. I'm just going to look at the ones on the top. So 3 times x plus 3. 3 times x is 3x. 3 times 3 is plus 9. And that is all over x minus 2x plus 3. I'm subtracting. So here I've got 2 times x, 2x. And I've got 2 times minus 2, which is minus 4. Now, this subtraction sign in the middle here, really important, yeah? What I am effectively doing here is I am subtracting the whole of this. So you have got to be careful with your signs, okay? Now I'm going to just write this out as 3x plus 9 minus all of that in brackets, because then it shows me that it's all of this that is being subtracted, including that minus 4. It's all over a common denominator, so I could write from the beginning of written it all over a common denominator. So let's just see what I've got if I multiply this out. Minus 2x, this is minus times the 2, and minus minus 4 is plus 4. All over x minus 2x plus 3. So finally then, simplifying the top, 3x minus 2x, I've just got 1x left. 9 plus 4 is 13. All over that stuff at the bottom. Now, I would be fine if you skipped some of these workings, but you must get this sign right. So from here, if you did minus 2x and plus 4, it would get you right down to here. You could skip all of those workings and come in down here. Now I can see that might be very attractive to you. You hate doing loads of workings, lots of you. I'm fine with that as long as you get your signs right. If you think you're likely to get your signs wrong, you show all your workings. Yeah, this is important. Yeah, this minus sign in the middle here applies to all of that. If you don't do that, you'll get your signs wrong, gents. Okay, so that was adding or subtracting, because the rules are the same. Algebraic fractions, they work the same as they do with normal fractions. Just going to have a quick look at this time then at multiplying fractions. So if I've got 6/5 times 3/7, this is the easiest thing to do with normal fractions, isn't it? You just multiply the top together, 6 times 3, you multiply the denominators together, 5 times 7, you end up with 18 over 35. Okay, so we're going to apply the same rule for algebraic fractions. So here, for multiplying, I'm going to say I've got 16yz over 5x squared times 4xy over 7z. All you do is multiply the numerators together and the denominators together, and that's it. So this is the easiest kind of work with algebraic fractions or with normal fractions. Okay, so I've got 16yz, and I'm going to multiply that by 4xy. I'm just going to put them in brackets like that so you can see what I've done. And 5x squared times 7z. Again, you could skip this stage, but I'm just showing you what's happening here. Okay, 16 times 4 is 64. Haven't got any x's on that side, so it's just one x. I've got a y and a y, so that's a y squared. I haven't got any z's on that side, so I've just got a z on the top there. 5 times 7 is 35. X squared times z, x squared z. Yeah, remember that rule, you just write things next to each other if they are the same letter. Okay, so multiplying for algebraic fractions, not difficult, just got to keep an eye on what you're doing. Last thing, and this is the very last thing, dividing. So our rule for dividing fractions, normal fractions, we were dividing 6/5 by 3/7, we would keep it, change it, flip it. keep the first fraction the same, change the division to a multiplication, and then take the reciprocal, flip the last fraction. Yeah? Just write that here. Keep it, change it, flip it. Same rule applies for algebraic fractions. Okay, so our last example, 5y minus 10 all over 15 divided by y minus 2 over 3y. Keep it the same. 5y minus 10 over 15. Change it. Change that division to a multiplication. Flip it. Put the 3y on the top and the y minus 2 on the bottom. Then you multiply through. Okay, so this becomes 5y minus 10. Now all of that is multiplied by 3y. And the 15 is multiplying all of y minus 2. Okay? Now you might not like this written this way around. It makes no difference. So I'm going to say same as 3y times 5y minus 10. You might prefer it written that way around, yeah? Better see it more easily. Okay, so everything outside the bracket has got to multiply by everything inside the bracket here. 3 times 5 is 15. Y times y is y squared. 3 times minus 10 is minus 30. Y. And then on the bottom, I've got 15y minus 30. Now, you've done the multiplying out at this stage. Final thing on this one though, I can see that I've got some common factors that could come out here. So I'm going to simplify this further, okay? Common factor on the top, well, they're both in the 5 times table. So 5, and they've both got a y in. So I'm going to put a y there, yeah? In brackets then, I would have a 3y to make the 15y squared, and a minus 6 to make the 30y. On the bottom, I've got 15y minus 30. There's a 5 that can come out of both of these. That would leave me with a 3y and a minus 6. So at this very final stage, I've got a common factor on the top and the bottom of my fraction, a 3y minus 6. They are exactly the same as each other. So because they're exactly the same as each other, we can divide through by them on the top and the bottom. The 3y minus 6 can be divided through. I am therefore just left with, and the 5 and the 5 are common to both. So I can just left with y over 1, which is y. So very last stage, this is simplifying by factorising. So I've done my division calculation by keeping it, changing it, flipping it. I've multiplied out. When I've multiplied out, I've realised that I've got some common factors on the top and the bottom. So I've factorised and then I've simplified. I think I'm going to leave it there, gents. So that is algebraic fractions. That's basically chapter 2 done. We'll do some more of this in our Teams lessons this week with myself and Mr. Vaughan. Okay, well done.